Picture this. You're inside a towering building, and suddenly, the ground beneath you begins to shake violently. The walls crack, objects fall, and the fear of collapse looms over you. But fear not, because you're in an earthquake-resistant building, just like Taipei 101. Stick until the end as we unveil the secrets behind these extraordinary structures that defy nature's wrath and explore other architectural marvels worldwide. Taipei 101. Taipei 101 in Taiwan is one of the most famous earthquake-resistant skyscrapers. It is one of the most mesmerizing super tall skyscrapers in the world. Completed in 2004, it used several advanced techniques to provide stability. The base of the building has massive concrete piles that extend over 100 feet into the bedrock, anchoring the tower firmly. The steel-framed superstructure has dampers that act as shock absorbers, absorbing the energy of an earthquake and dissipating it as heat. The dampers are huge metal balls that counteract significant transient loading like wind and earthquakes to reduce the sway of the skyscraper. Over 800 of these giant steel pendulums help Taipei 101 sway up to 4 feet in any direction during an earthquake without causing structural damage. These innovations allowed Taipei 101 to withstand several strong tremors with minimal effects. Our next building is one of the major airports in the world, serving the historical city of Istanbul. Sabiha Gokcen International. Sabiha Gokcen is one of the world's most earthquake-proof buildings. The airport also utilizes state-of-the-art earthquake engineering near the North Anatolian Fault in Istanbul, Turkey. It was designed by an engineering firm, Oveyarup, to have 300 base isolator systems that can withstand an earthquake of up to a maximum of 8.0 on the Richter scale. The base isolators can reduce lateral seismic loading by 80%, making it one of the largest seismically isolated structures. The airport's iconic terminal building is shaped like a giant tulip, with petal-like roofs extending over the concourses. The structure's lightweight steel frame has strategically placed braces that help it resist seismic forces and return to its original shape after an earthquake. The foundation of the building consists of over 2,000 piles that extend over 130 feet into the bedrock, providing a stable base. These design features have enabled the airport terminal to withstand several earthquakes in the seismically active region around Istanbul. From Istanbul, our next destination is the entertainment hub, California. The Transamerica Pyramid. The Transamerica Pyramid in San Francisco is another famous structure that survived multiple earthquakes. Built in 1972, it has a reinforced concrete core that acts as its spine, providing most of the building's stiffness and strength. The pyramid's steel frame is bolted instead of welded, allowing the structure flexibility during shaking. The foundation uses over 500 concrete piles that penetrate over 100 feet into the bedrock, securing the building. These earthquake engineering techniques have allowed the pyramid to remain standing, even after the 1989 Loma Prieta earthquake that registered a magnitude of 7 on the Richter scale. And now, we visit one of the most iconic super tall structures in the world, the Burj Khalifa. It would be a shame if this iconic skyscraper was unprepared for natural calamities. But thanks to the engineers, they made it earthquake resistant. The Burj Khalifa in Dubai, the world's tallest building at over 2,700 feet, also employs advanced earthquake engineering. While Dubai is not a seismically active zone, the Burj Khalifa was designed to withstand earthquakes up to magnitude 8. The structure has mechanical floors, where outrigger walls connect the perimeter columns to the interior wall. The reinforced concrete core houses elevators and staircases, providing most of its stiffness. The outer steel and concrete frames acts as a second core, absorbing and dissipating energy during shaking. Over 1,500 piles anchor the building's foundation into the bedrock. The Burj Khalifa was also designed to sway up to 3 feet in any direction during an earthquake. These innovative earthquake-resistant features ensure the safety and stability of the world's tallest structure. Coming up next, we explore the Philippines as it stands strong in the realm of earthquake resistance. The Philippine Arena. The Philippine Arena in the Philippines is the largest indoor arena in the world, and it was also designed to withstand earthquakes. The structure is owned by the Christian group Iglesia ni Cristo. Completed in 2014, the dome-shaped arena uses a steel space frame structure to flex and sway during shaking. The steel frame is bolted instead of welded, enabling it to absorb the energy of an earthquake. The Philippine Arena's foundation consists of over 1,000 concrete piles that extend deep into the soil, tying the structure securely to the ground. These earthquake engineering techniques have enabled the massive indoor arena, which seat over 55,000 people, to remain stable even during tremors. Continuing our journey beyond the Philippines, we now turn our attention to Japan, where the country's technical expertise shines in safeguarding megastructures against earthquakes. Tokyo Skytree. One of the most earthquake-resistant buildings in Japan is the Tokyo Skytree. Standing over 2,000 feet tall, Tokyo Skytree has become a symbol of Japan's technological advancement. The tower's unique elliptical shape helps it withstand powerful tremors typical in the earthquake-prone nation. Its steel frame is designed to flex and sway, absorbing much of the shock before it reaches the upper sections. Dampers act like shock absorbers, further reducing vibrations. As a result, the tower can endure quakes up to magnitude 8 on the Richter scale. Utah State Capitol. Across the world, in Salt Lake City, Utah. The state capitol building has withstood multiple significant quakes since its completion in 1916. The limestone and granite structure was designed using base isolation technology. It rests on massive steel plates supported by steel rollers and lubricated with oil. During an earthquake, the building essentially floats on this isolation system, allowing it to move independently of the shaking ground. The Capitol's dome also acts as a counterweight, helping stabilize the structure. As the earth convulses in its restless slumber, the state capitol building of Salt Lake City stands tall, an unwavering testament to the indomitable spirit of mankind. These advanced engineering solutions demonstrate that buildings do not need to be helpless victims during earthquakes. With the proper design and materials, we can construct tall towers and critical government facilities that remain standing, despite violently shaking below them. The key is to allow the structures to flex and move, isolating them from the destructive forces of an earthquake. As we build in seismically active regions, earthquake resistance must become fundamental to architectural planning and design. Thank you for joining us today in the journey of megastructures and architecture. For more of this content, watch our previous videos. We are happy to keep you informed and entertained. Hit that like button, subscribe, and let us know which of these is your favorite skyscraper.